Okay, so my dear student, exercise 9.5, it's a question number 5, which is quite very important for the exam. Okay, show that. What we have to show in the question? First, we are given in that 3x plus 7 whole square minus 84x, which is equal to 3x minus 7 whole square. Fine. This is the question, fine. Now, how to go with that? How to work out upon that? Very simple, very easy. Let's begin with LHS. Okay, there are two options, LHS and RHS. First, we need to work out on LHS. We will simplify and then we will work out on RHS. And if LHS equal to RHS is coming equal, that we have already proved, that is clear. Now, let's note down what we are given in LHS. The question says 3x plus 7 whole square minus 84x. This we are given, right? This is the LHS question given. Suppose for a while, think about this much part, okay? This much portion, you think about that and forget this part, okay? If we focus on this much portion, I am hiding this much. So at that time, the square of this is the square of algebraic expression, sorry. This is the binomial, it's a square. This term we need to apply the identity, that is first identity we are going to apply for that, a plus b whole square. So the identity says a square plus 2ab plus b square, which is minus 84x. Okay, fine. So you can see here, what is A? A is the first term. A is the first term, that is 3x. Here also I am writing 3x. Second term is 7. Here I need to write 7. Clear to you? So dear student, equal to, here equal to is there. Let me simplify. What is 3x whole square? We know that 3 square is 3 3 9. Okay. 3 square indicate 3 multiplied by 3, that is 9. Along with this x square. Fine. Plus. Now let's work out this. All three terms are connected with product sign. Okay. There is nothing between them. Always consider product. So 2 3 6, 6 7 42. So I need to mention 42x. Here 2 3 6, 6 7 42 along with this x plus. Here it is plus. What is 7 square? 7 square is 7 into 7, that is 49. Fine. Minus 84x is already there, extra term. Let me open the bracket. Okay. If I open the bracket, then 9x square plus 42x plus 49 minus 84x. Okay. Now, after opening the bracket, we can see here these two terms are in like terms. They are in like, the two terms are like terms. Why? Because here it is having x variable. This term is also having x variable. So let's work out. Our answer will be 9x square. Why here it is plus 42 minus 84. Means we need to subtract opposite sign. We need to subtract. So 84 minus 42 gives the result 42. Fine. 42x. But how can we decide the sign? Which sign should we keep here? Of course, the big number sign. The big number out of these two is this one. So its sign is negative. So I am writing minus here. And of course, one more term is left, that is plus 49. Let me write it as. This is the simplification of LHS portion. Okay. First, what I have done here, I apply the identity for this much portion. That is first identity I applied a square plus 2ab plus b square. And at that time, I kept this term as it is. After simplification in the bracket, I open the bracket and I sort out these two like terms. So I have this term as a result. These three terms That is expression 9x square minus 42x plus 49 as a result. Clear? Now let's work out on RHS, right hand side. What we are here in the RHS, let's note down, that is 3x minus 7 whole square. Right? This we are given. So here we can see, we can apply here second identity. Okay, it will work out with the second identity. So as we know that second identity says a square minus 2ab plus b square. Fine. A square minus 2ab plus b square. What is a? What is a? That is 3x. This is also 3x. What is b? That is 7. b 7. Fine. Let's simplify it. 3x whole square. So 3 square, it will be 9x square. 3x whole square means 3 square will be 3 3 cha 9 minus. Here it is minus 2 into 3 into 7. It will be in multiplication 2 into 3 into 7. 2 3 ja 6. 6 7 ja 42. And this is x. So here it is 42x. Fine. Plus 7 square is 49. 7 square it is 49. Now you compare. Okay. We can see here this is our LHS and here RHS. Okay. So here we can say hence hence LHS equal to RHS. Both are coming similar. Okay. So we need to write it is proved. In bracket we need to mention here proved. Proved. Here I have written proved. 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 LHS equal to RHS, that is proved, because these three terms similar with these three terms. Clear? So, my dear student, let's work out upon this. What we are given here, just look at your screen. Second question is 4p minus 9p minus 5q whole square plus 180pq, which is equal to 9p plus 5q whole square. Fine. So, we will start with LHS first. So, let me note down left hand side. The left hand side is 9p minus 5q whole square plus 180p. This we are given, right? Let's work out upon this part is this portion I am working upon and this separately. So for this first part, if I am working, then we can compare. We need to apply here second identity because of minus and the square is already there. So we need to apply second identity. So let's work out further. If we apply second identity, then of course we will have here a square minus 2ab plus b square plus 180p. This we are having. Fine. So what we have to do? Let's write A. What is A here? That is 9p. What is A? 9p. What is B? 5q. What is B? 5q. So you can see here I have applied the value of A. Here it is B. Now let's sort out this. What is the square of 9? Of course it is 9 9 ja 81 along with p square. Okay, square of this number also minus. Find minus. Let's multiply this three terms because they all three terms are connected with product. Okay, so what should I write after multiplication? 2 into 9 into 5. As we know that 2 9 ja 18, 18 5 ja 90. If not, then you can see 5 2 ja 10, 10 into 9, 90. And along with this P and Q in product. So I need to mention this is PQ plus. Next step plus. What about 5Q whole square? We know that, dear student, here 5 means 5 square means 5 into 5. 5 5 ja 25. And of course the square of this variable also, so it will be q square. Fine. and one additional term is here, that is plus 180 PQ. I am putting it here. Now observe carefully, there is some like terms. Which two terms are in like? You can see this term and these two terms. Minus 90 PQ plus 180 PQ, they are like terms. So what will be the answer? If I note down properly, then this first term remains same. Let's work out upon this. Minus 90 PQ plus 180 PQ. Minus 90 PQ plus 180 PQ gives the result 90 PQ. From where this coming? 180 minus 90, it gives the result plus 90. And of course, this is 25 Q square is already there. Okay. So this is the simplification of left hand side. Fine. Let's work out on RHS. What is RHS here? Right hand side. Let's note down. RHS is this much. 9P plus 5Q whole square. Fine. 9P plus 5Q whole square. So we can compare. Which identity we need to apply to sort out this? Of course, here square of these two binomial square, and here we need to apply first identity because of plus here. So which is the first identity? It says a square plus 2ab plus b square. This is the first identity, right? So let's put the value of a. What is a here? In identity, we used to write a square plus 2ab plus b square. What is a here? A is 9p. Here also 9p. What is b? That is 5q. What is b? That is 5q. 5 equal to. Now, what is 9p whole square? 9 square. 9 square, it will be 9 9 ja 81. And what is p here? It will be p square. 81 p square. Plus, what about this? These three terms are in product. So, what do we have? We need to write 2 into 9 into 5. 2 into 9 into 5, we know 2, 5 to the 10 into 9, that is 90. P into Q gives the result PQ. Plus, what is PQ square? That is PQ square is 25Q square. Fine. PQ square equal to 25Q square. Now observe. What about this RHS? RHS, LHS and RHS, are they similar? Just check it. Of course, these two terms are, this full expression is equal. Okay. Both are similar. You can see all these terms are similar. No changes of even sign. Okay. So final answer we need to write hence LHS equal to RHS. Fine. LHS equal to RHS. So we need to write hence proved. We need to mention it is proved. Means we are successfully proved that LHS and RHS, they are coming similar. If you do not want to write LHS equal to RHS, then you can mention this full question also, and final answer hence proved. Clear to you? Okay, my dear students, now we'll work out on question number 5. It's the third question. Okay, very important for the exam purpose also and for the knowledge purpose also. Reason behind that, here we are going to apply the identity for rational number. Okay, that is fractional number, right? So how to solve? The question is 4 by 3m minus 3 by 4n whole square. WHOLE whole square plus 2mn, which is equal to 16 by 9m square plus 9 by 16n square. Okay, this we need to prove, which is very simple and very easy. So first of all, let me note down what we are given in LHS side. The LHS says 4 by 3m minus 3 by 4n whole square plus 2m. Okay, whatever we are given in the LHS portion, I have written it as it is. Okay, now I am separating this given expression in two parts. This is first part, this is second part. So far we are working on the first part only. Okay. Think that here it is a square of this binomial. Fine. And between that minus sign, so which identity we need to apply? Of course, second identity because of this minus. Okay. So what is the second identity? Let me write it here in proper way. A square minus 2ab plus b square. Fine. Bracket over. And this additional term 2m I am writing here. Here to you, what I have done? Nothing. I have applied the identity only. What is the identity? According to that, I have written here a square minus 2ab plus b square. Now, what is a here? What is a here? That is 4 by 3m. Here it is also 4 by 3m. What is b? That is 3 by 4n. Here also 3 by 4n. We know this is A, this portion is A, and this we are comparing with B. This first term is A and this is B. Fine. So now let's simplify it. Be careful. You need to be very, very careful while simplifying. You will find it easy. Look at your screen. What is the square of 4? Work out upon this. 4 square is 4 into 4. That is 16. 3 square 3 into 3, that is 9. And along with the square of this variable also m square. Here minus. Now think about this. What is the relation between these two brackets? They are connect with product. So we can directly cancel here. 4 4 cancel. 4 4 cancel. 3 3 also cancel. Fine. So what is left here? Because all three terms are connected with product. So here it is 2 left and m into n, mn left. So let me write it as it is plus. Now plus. Here 3 by 4n whole square. How to simplify? 3 square is 3 3 ja 9. 4 square is 16. And along with the variable square. So it is n square. Fine. This is the simplification of this bracket. But here one additional term is there. Okay. That also we not forget to write. We do not have to forget to write it over there. So it is 2mn plus 2mn I am writing here. We know that this minus 2mn plus 2mn. It will be cancelled. So what is left? So 16 by 9 m square plus 9 by 16 n square. Okay, this is the remaining terms. Now you can see this is as similar as asked in the question. So directly the LHS as we started solving the sum, and finally the answer which we are gaining, that is equal to RHS. So without solving RHS part, here RHS is directly with us, right? So finally we should say here we need to write LHS equal to RHS, hence proved. We need to mention hence proved. This we are already clear to you. So my dear student, just look at your screen and see question 5 show that in the fourth part. The question says in the first bracket 4pq plus 3q whole square minus, between that minus sign is there, 4pq minus 3q whole square equal to, we need to prove 48pq square. Okay, means our answer should be this. Okay, so let's begin with LHS portion. What we are given in the LHS, let me note down here. LHS equal to, so I am writing here this way. LHS equal to, I am writing LHS now here. The equation says 4pq plus 3q whole square minus, in another bracket, 4pq minus 3q whole square. This is the question, right? Simply I have done nothing so far, only I have Carefully, I have written the question in LHS. Fine. Now, look at the screen and think about the two parts. This is first part, this is the second part. And work out on first part first. First part we can see because of the square of binomial and between that plus sign. Here for this we need to apply first identity, and here it is minus. So here for this much portion, his this much part 2, we need to apply second identity. Fine. You know very well which is our first identity. So first of all, I am writing the identity, that is a square plus 2ab plus b square. Bracket over. Between that, which sign is there? Minus. So here not equal to. This is minus. Now I'm going to write the identity, second identity for this much portion. So it will be a square minus 2ab plus b square. Fine. So, my dear student, here we need to put the value now. Okay. Now, what is A? If we compare, the first term is A and this second term is B. And as we know that here we need to write A first, 4pk. This is also first term 4pk. Second term is P2. Here also second term P2. Fine. Same thing I am going to apply for the second part here. Here in these two terms, this is the first term which we are going to compare with A, and this is our B according to the identity. So I need to write the value of A here 4pq. This is also 4pq. Here it is 3q, and this is also 3q. Fine. So let's simplify. Make yourself ready. So, first of all, we know 4 square. What is 4 square? 4 square, it will be 4 into 4. 4 4 just 16. P square, Q square. Right? The first bracket I need to write 4 square will be 16. P square, Q square. Plus, here plus sign. Okay. All these three terms are connected with product sign. Okay. So we need to multiply. We know that 2 4 cha 8, 8 3 cha 24. So I am writing here 24. P is already there, and q into q, that is q square. Clear to you? Once again I am explaining. 2 4 cha 8, 8 3 cha 24. P is already there, q into q, that is q square. Plus, let's work out on 3q whole square. What is 3? Square of 3 is 9. What is q? That is q square. That is 9q square. Clear? Between this, you can see here minus sign. So let me write minus here. And now I'm going to simplify this second part. Okay? Between these two bracket, I have written minus here. Clear to you? Now let's again work out on this, the square of 4pq. As we already know the square of 4pq, it will be 16 p square q square, square of both of the variable also, minus. Now let's multiply these three terms because they are connected with product sign. So 2 4 cha 8, 8 3 cha 24. So I'm writing 24 along with this pq into q. P is only single time, but Q into Q two times gives the result Q square. Fine. Plus, you can see here 3 square. That is 3 into 3, 9. Along with the square of this variable, that is Q square. Let me open the bracket now. Okay. So, first bracket, whatever is with us, it remains same. Okay. So, let me write what we are having in the first bracket. 16 p square q square plus 24 pq square plus 9q square. This is first bracket. Now, as we know that, because here it is minus sign, okay? Because here it is minus sign, here I am writing minus, and I need to change the sign of all the terms present inside the bracket. So first I am writing all the terms. Here it is 24 PQ square. Fine. And this is 9Q square. Clear? Now, as we know that because of minus outside the bracket, this minus, so this term will become plus. As here it is plus, so this term will become minus. Now, after doing this much, just observe, is there anything which they are in like terms? Yes, I can see here these two terms are like. Okay, these two terms are like but with opposite sign. Here the sign of this is plus 16. Here it is minus 16 and this much variable is p square q square similar. So opposite sign it will be cancelled. Same thing I can observe here. These two terms are also like with opposite sign. You can see plus 9q square. This is q. Okay. And this is minus 9q square. This will be also cancelled. Now what is left over? Let me write what is left with us. 24 pq square plus 24 pq square is left. Okay. We know that they are also in like terms. 24 plus 24 gives the result 48 pq square. Fine. So this is the simplification of LHS. But if we look at the RHS portion which we have to compare, the answer is coming similar. You can compare, the answer is coming similar. So only after the simplification of LHS, we are able to find the answer which is equal to RHS. Fine. So let me write it RHS. And here, as you know what we have to write, last line we need to write LHS equal to RHS. So let me write it here. LHS equal to RHS. We know LHS equal to RHS. So what? So we can say hence proved. We need to write here hence proved. Means whatever we are asked to prove, that we have proved that LHS equal to RHS. Clear to you? So my dear student, here the fifth question of the fifth question, it's a fifth part, okay, which is quite important for the examination purpose and easy also. You can see on your screen what we are given in the question. A minus b, a plus b, plus b minus c, b plus c, plus c minus a, c plus a, which is equal to 0. Clear? So let's begin with LHS. Okay. So let me note down LHS equal to. What is LHS with us? A minus b, a plus b. I'm writing in one bracket. Then b minus c, b plus c in another bracket, plus c minus a and c plus a. That we need to write it. Whatever we are given, nothing I have done, only I mention as it is here in LHS portion. Now let's work out and think about that. Which identity we need to apply here? All of us, we know that here there isn't any square because both these terms are not similar. They are with opposite sign. Only their first term similar, second term similar. So here in such a case, we need to apply third identity. What is our third identity? We know a minus b, a plus b. That is for this is we are having the identity number 3 here also for third identity, and for this also we will apply third identity. Means individually we are going to apply the third identity. Now third identity is a minus b, a plus b equal to, that is says a square minus b square. Fine. This is very important and easy identity between that plus sign. So another I am going to write next step here with the plus sign. Plus I am writing here, and we know that here a square minus b square, plus here again a square minus b square. Fine. Once again, what I have done, only and only I have written here third identity, that is application of third identity says a minus b, a plus b, opposite sign, so we need to write a square minus b square. Fine. So which is, what is a? A means first term. First term is already A here. What is second term? Second term is B here. In this also, what is first term? That is B. What is second term? That is C. In this also, what is first term? First term is C here. What is second term? That is A here. Okay. Now, let's simplify. Here it will be A square minus B square in one bracket plus second bracket B square minus C square plus third bracket C square minus A square. Let me open all three brackets now. So A square minus B square plus B square minus C square plus C square minus A square. Fine. This we are given. Now observe carefully. Something is in the like term. Okay, which are in the like term? So here A square minus A square. So let me write it together. A square minus A square. Then minus B square plus B square. That is also, and here minus C square plus C square. That is third part. So dear student, if we go with it plus and minus, like term cancelled, minus plus cancel, minus plus cancel. All the terms cancel, so answer is 0, which will be equal to, which we have to prove here, equal to 0. So I need to write that is RHS. That we have proved. So final answer we need to write here LHS equal to RHS, hence proved. Okay, we need to mention hence proved. So in for that type of question, it's compulsory to mention this last step, because as we begin our sum with LHS and successfully we reaches to our RHS. So this is proved.